It's important you recognize this is integration by parts type 1, where you want to let u equal to the x term and the dv equal to the sine of 2x dx. All right, so then we're going to take the derivative of this one, and then we're going to take the antiderivative, and I call this the La Jolla theorem, where we just take the 1 over the 2, and because you know the derivative of cosine is negative sine, we have to put a negative here. Okay, so this gives us uv negative x over 2 cosine of 2x minus the integral of v du. And so the question is, can I take the integral of this? So I'm just going to take the time to rewrite everything, move the number on the outside. Do we know how to take the antiderivative of cosine of 2x? We do. So negative x over 2 cosine of 2x, carry along the 1/2, and this will be 1/2 sine of 2x plus a c. That's the answer. All right, so let's do this next one. I'm going to take liberties and erase here. So you're looking at this next one and you're seeing that the x is squared, very much like the one in the example in the notes. This means I'm going to have to do integration by parts twice. So let's do it. So, come on, there we go. Okay, so I'm going to let u equal the x squared, and then the dv equal the e to the negative x. So du is 2x dx, v is negative, because you know it's like the La Jolla theorem, right? Integral of e to the ax dx is 1 over a e to the ax. So the a is negative 1, so I just get 1 over negative 1. So this is so powerful to not have to do the u substitution every time you do this. All right, so let's plug it all in. So uv negative x squared e to the negative x, sorry, it's kind of messy, minus the integral of v du. So, this should, no, yeah, v du, sorry, negative e to the negative x, 2x dx. Okay, so let's see what we've got. I would always suggest, it's not necessary, but I would always suggest cleaning up what you've got. So negative, negative, and a 2, so positive 2, x e to the negative x dx. Now, oh, look at that. This is another integration by parts where you let u equal the x. The dv is the e to the negative x. So v is negative e to the negative x. Du is dx. Okay, so then this part here carries along. So negative x squared e to the negative x plus 2 that carries along. And now we're going to do parts on this. So that's uv minus the integral of v du minus this. Okay, so let's see what we've got here. So let me carry it down here. So negative x squared e to the negative x plus 2. And it's not going to be necessary for me to multiply all this out, so I'm not. So then I'm going to say this negative negative makes a positive, and then integral of positive e to the negative x gives me a negative e to the negative x. And then I put a plus c at the end. All right. So let's see, the next one was number 3. And look at that. The e is in the denominator. So anytime you're doing parts, you don't want fractions. So what you're going to want to do is rewrite that e to the 3x from the denominator as e to the negative 3x. And then that will be an easy integral. Sorry, this is taking a long time to erase. Okay, here we go. So if I let u equal x, and literally I'm rewriting this as x e to the negative 3x, right? And then dv is e to the negative 3x. So v, taking the antiderivative, would be a negative 1/3. And then the du is dx. Okay, so put that together. So I get uv x negative 1/3 e to the negative 3x minus the integral of v negative 3x du. Okay, it always is helpful to just worry about pulling the numbers on the outside before you go worrying about taking the antiderivative. So this gives me a positive 1/3. And then I still have this e to the negative 3x dx. So this just carries along, this negative x over 3, e to the negative 3 over x. And I carry this positive 1/3 along. And then when I take the antiderivative of this, that gives me another negative 1/3 e to the negative 3x plus a c. All right, let me just finish it up here with this last one. And you can see I've got the answers written down here. There we go. Okay, so this is a type 2. Number 4 is a type 2. So this is where, since we know the derivative of ln of x, we want to let that be the u when we're doing the integration by parts. So let's do that. So I'm going to let u equal ln of x, and then the dv is x to the 5th dx. Get rid of some of this up here so it's not so congested. Okay, here we go. So du is 1 over x dx, and then taking the antiderivative, I get x to the 6 over 6. So let me take liberties here and just move upwards with this one. So I'm going to do, you got the parts down, uv minus the integral of v du. So you have to have that memorized, right? So I get uv, so x to the 6 over 6 ln of x, minus the integral of v, x to the 6 over 6 du. Oh, will you look at that? So what happens in here? There's some canceling going on, right? So I get to cancel, and then that's going to be an easy antiderivative. So let's carry everything along. So careful to carry everything along because it does matter. So I'd have a minus 1/6 x to the 5th, and then you would go take the antiderivative, and I'd get another 1/6 x to the 6th plus a c.